Alright, so we'll be talking about electrical system and the techno. So here's kind of just a basic schematic of where each things are located. So we have the main battery here, we have our alternators inside the engines, we have an external power receptacle back here on the telecone, and then we also have our emergency battery in the back there as well. We'll talk about an easier schematic to read in a second. So what our alternators do is it's providing primary DC power. It operates in parallel during the normal operations of the engines when the engines are running. Engine driven via a belt drive, so we can look inside right behind the propeller. You can see the belt. That's what's driving your alternators on each engine. Each alternator is rated at 14.2 to 14.8 volt, 40 amps. This is because we want to have more power to charge the batteries, which is a 12 volt battery.
You know what's interesting about the amps part? 40 amps is all that thing's kicking out. So if your radios are hogging 5 amps and your transponder's hogging 10 amps and your pitot heat's hogging 8 amps, it doesn't take much until you gobble up all the amps of a single alternator. So combined, I wonder if we're getting 80 amps when they're both like what's actually hitting the bus bars.
Yeah.
I'll have to put that on part 2.
Yeah. Then automatic lower voltage devices.
An integrated regulator.
So here's just kind of what the alternator looks like on the performance. So here's
So each alternator, this is for a single alternator, as you're spinning it at, so that's the propeller speed on the bottom, and then they've got the generator speed, so it's pretty much double, well, more like triple. When your propeller's spinning at 2,000 RPMs, your generator's spinning at 6,000 RPMs.
Yeah.
Because it's actually bolted right to or belted right to the engine, not to the propeller.
And there's your amp, so as you're increasing your power, you get more.
Up to on one, they've got it upwards of below 50 amps, but
So
above
45.
above 40 amps.
Looks like about 45 amps per alternator. Alright, so our main battery, so it's providing secondary DC power. It's a 12 volt 38 amp hour and 20 hour runtime. So the main battery in a single alternator can supply electrical power for the entire flight, but redundancy is diminished. We'll kind of talk about the schematic of what happens if your alternator did fail and stuff like that. Your main battery can supply power for at least 30 minutes of flight time. External power, so 12 volts DC connected to a battery relay via the external power relay. So I don't really know.
Let's go back a slide. So connected to the battery relay via an external power relay. Yeah, part 2 of this, we'll talk about why there's a battery relay and an external power relay. I want to say that when it comes to the relays, you've got the starter is going to shoot a giant high voltage blast to power the starter, and in order for us in the cockpit to have like a switch that was able to handle that giant of a load, what instead you want to do is just shoot like throw the switch in the cockpit that just energizes a what's that word, like a solenoid, and then the giant voltage can go through the solenoid into the starter, and it's just a more convenient way of doing it, but we'll have to break down exactly what's going on there on the next one.
Yeah. We'll talk about buses, like where the buses are located in the electrical system as well, but each bus is providing power for different things in the plane. So we'll be talking about, so we have the battery bus, we have the left alternator bus, right alternator bus, avionics buses here. We'll talk about the schematic in a second here. But this is just talking about the battery bus, what it's providing power to. So your audio panel, your primary flight display, your cooling fan, converter run, your fuel pressure gauges, your quantity gauges, oil pressure gauges. So it talks about this all in the airplane flying handbook, what each bus is going to be providing power to.
On the POH.
Avionics lights, strobe lights, flaps. So here's a easier schematic of the electrical system here. So you have your switches inside the cockpit here. So here's your master switch, your left hand field switch, right hand field switch, your left hand right hand avionics, your left hand right hand cross buses. Then inside the electrical system you have your left hand cross bus, your battery bus here, your right hand cross bus. Then here's your avionics buses here, your main battery, your emergency battery here, your two alternators here. So what this is doing is when you push your master switch, you're going to be connecting this circuit right here. See how it's kind of off to the side here, so it's not connected, but when you push that switch you're going to be connecting those electrical lines, that circuit, and so you're going to be providing power from your main battery into your battery bus. And then when we start the engines, we're going to be turning on our left hand field, right hand field switch. Obviously each engine will be doing that and stuff. So when we turn on our left engine, we're going to be flipping that switch, and then once the engine's going, we're going to be getting power from our alternator, and that circuit's connected as well. So we're going to get power from our alternator. It's going into our left hand cross buses. Once our engine's on, we'll be turning on our avionics switch and our left hand cross bus switch there. And so what that's doing is connecting all these circuits right here. So we're getting power from our alternator into our cross buses, powering our avionics bus here, and then it's providing power into our battery bus here.
Gotcha. And then you start the right engine, turn on the cross bus and the avionics bus and the right engine, so that'll connect him to the alternator, and then I'll have the alternator going through the cross bus to help power the main battery bus.
Yep, so we're getting power out to there, charging so we're getting 14 volts from the alternator. All this power is going through here, charging your main battery there.
Okay, so then if the right alternator fails, like a wire wiggles off or over voltage on the right side, then how does the left alternator supply all 5 buses with electricity?
Yep, so if you have your alternator over voltage on this one, so you're turning off your right hand field switch, it's disconnecting that circuit right there. So what this alternator is going to be doing, since these are all connected still, you're still getting power from all these buses into your battery bus and connecting power into here.
Nice.
So that's a good thing about having 2 alternators, is you can still get power. You may have to turn off a few things in the cockpit, so you might have that redundancy, but you'll still have power for your flight to get back safely.
Got it.
Then we have our emergency switch here. So in case anything ever happens, like we can't start the plane or whatever, we can flip the emergency switch here. We have our backup battery. So you're connecting that circuit here. You get power to start your engines and stuff like that. So,
you know what's interesting about that? Sorry to segue all the time, but when we shut down an engine in flight, that propeller continues to windmill out there. So it doesn't just come to until we feather it, it's just going to sit there and windmill. And so when say we're up there and we feather the engine, like we're just practicing feathering the engine, and we go to start it again, that's when the backup battery is going to come into play, if I understand. And I'm just kind of brainstorming or like comparing notes with you now. Like say you're up there and you got one feathered engine and one regular engine, and you're sitting there starting the feathered engine. It's like you drain your battery. You're like, okay, there isn't some sort of a accumulator to help bring like pressurized oil that unfeathers the prop. All you've got is electric power to unfeather your props. And so then you're like, well, battery 1 is totally drained. Let's try battery 2 and see if we can get that feathered.
Never tried that in flight.
What's that?
Never tried the backup battery in flight
I
because it
think,
always starts up.
yeah, but I think that's what it's there for, is in case you need a little extra bump of electricity up in the air to get your feathered
Engine going.
engine going.
Yeah.
Because there's no, like, you don't have an oil accumulator like the Seneca and the Baron do
Yeah.
to help unfeather a prop.
Yeah.
This is great. What's on your next slide?
Ignition.
So let me just ask you one more thing. So say it's a cold, dark night, and we lose both sources of power, both alternators. So we're just having a bad day. We'll drain the battery after 30 minutes, because then it'll power our G1 or our G950 devices, and then when that goes kaput, then we can use the backup battery in that case as well, and
That's
it
probably like 30 minutes
will,
too.
huh?
So that's probably like 30 minutes too.
Yeah, so then you got an extra 30 minutes. But I'm trying to think if we got a bunch of backup gauges there and a big floodlight, and I might be getting this confused with the diamonds, but eventually if our G1000 goes out, then is the situation we're just operating an attitude indicator and a floodlight and using the attitude indicator. I think that's what this is saying, is you got a standby attitude indicator is connected to the emergency battery. So heaven forbid, cold dark night, and you lose both alternators and you're an IMC, you've got the redundancy to at least have an alternator and a floodlight, just like the DA40.
Yeah.
Because I think that's what happens in the DA40 is you've got the battery dies, but there's a second backup battery with a little, it's like got a protected switch, and so you undo the wire and flip it, and you've got an attitude indicator and a floodlight for another 30 minutes to at least get to the ground. Yeah.
Yeah.
I think it's the same system, the same setup.
Is it?
Which makes sense because they're both G1000 varieties. I'll have to double check that and see if there's a correlation there.
Yeah.
All right,
So-
that's great. Is there any more to the electrical?
No.